Good morning, everyone. Happy Wednesday. I've got my tea here in front of me, and I'm ready to continue learning a little bit of specs. I realize that my the chat I have like right underneath the light, so it's impossible to read in that position. So I think I want to move that down. Maybe I'll just have it on this tablet, like I have in the past. Okay, so UT can go over there. I'm going to move the mic, so I'll mute that first. All right, there we go. I think we're all good. Have everything set up. So I did notice that like down here in this area, it's not like quite catching. And I think it's because the from when I had the green screen in storage, in a way I'm sort of like keeping it after between streams, it's a little bit wrinkly. And so especially down there, it might also be like a light problem where the light, like that's also the darkest area for that green. There's probably a way for me to fix that. I just have to figure out like either an optimal lighting solution or something else. I'm not going to worry about it right now, but maybe in the future we'll have something set up. So as to what we're doing today, we're continuing the learning process for specs and GGEZ in Rust. So ECS is what we have last time is we're registering three components, position, a size, and the rendering of the actual circle itself. And I've been thinking about this, and I watched a really cool presentation by the Unity team about them bringing ECS in. And it looks like their suggestion was they're just creating the meshes every frame. And that's how they're able to handle like where things go. And as I was thinking about that, I realized that that's how a camera system could potentially work too. Because if I have my, like, let's say I have a circle right here, and I say like, okay, your unit of size is 50 pixels radius. But then I want to zoom the camera out so that more things are on display at the same time. I need to then use the scale of the the scale of the display, the draw function off of graphics, in order to make it look smaller as the camera is like zooming backwards. Right now, the way I'm doing it is I couldn't do that because this basically says I'm 1 unit, I'm 1 pixel in size, but go ahead and set me to the right size at the draw state. So I lose any ability to do camera work in the future, which I think would be really important for the ecosystem project because we're going to have a lot of elements on the screen and it's going to get too tight. It's not going to be as interesting. So having a bigger world, but we only see a small part of it at one time, or we can zoom out to see all of it, I think that would be really nice. So I'm going to actually, well, I'm probably going to remove the circle part and instead replace this with basically a generic render component. Danny Fritz, good morning, hello. Something else that, and this is what I kind of want to work on today, is the idea of moving two different entities, and then if we have time, the idea of like a collision detection between the entities and knowing if we've touched each other. The issue that I've seen, or rather what I haven't seen in the book so far is how to iterate over a list of other entities at the same time. And what I mean by that is, if we take a look at the book here, we see the ability to use the join off of components in order to get like the full list of all the components. But then inside of that, for each of these components, I want to like now be able to compare myself with other components. And I don't see a way to do that based upon this tutorial. Maybe there is a way off of something else. So collision detection, I think, is going to be interesting. I know, Danny, you had an example with collision detection and specs, so I might take a look at that. I think you used a library for the collision detection part, though, as opposed to just sort of calculating the location and whether or not they were colliding. So I might take a look at that later. Until then, let's see if we can get... Yeah, you were using a BVH to do that. What's BVH stand for? Boundary vertical horizontal? I can't believe it's that. I'll leave you here. Bounding volume hierarchy. Ooh, that might be interesting to look into. Was there a specific library for that, like a crate? So creates.io BVH. N-collide by the N-algebra creator. Okay. N-collide. Which, oh, deprecated. Use N-collide 2D or N-collide 3D instead. Okay. 2D. A 2 and 3-dimensional, really, a 2 and 3-dimensional collider, except there's also an N-collide 3D. Okay. So this might be good. This is creates IO version 0.0.0. So it seems new. Yeah, it started with 0.19 in April of this year. So we could play around with this in another in the future once we get to that point. But until then, what I want to do is I want to get two sort of circles in the world, and then make them not make one of them a mover and one of them not a mover. He started with N-collide and then continued with N-collide 2D, 3D. Yeah, it looks like sort of going through that direction and then realizing, oh, I should break these out into different ones because there's different logic in it, or it maybe became too big. I haven't obviously haven't looked into it at all, so that's just what I think would happen to me potentially. So refactoring. Let's make let's change this circle component. So right now this is creating the mesh. I'm thinking that I don't necessarily want to do this. Right now let's just have everything be a mesh. So I'm not going to use that. So let's not add you in. Let's not create you. He kept his types more succinct, splitting it because the library's types are always too much. Oh yeah, his libraries, he has so many types in his libraries. Definitely true. Okay, so then our draw circle systems. So I really think that this should be renamed to a render system. Okay, so we don't need circle to be brought in. We just need position and size. We're not bringing in the mesh. We use join, not bringing in you. So now we can draw. So we need to create the mesh for every one of these. So let mesh equals graphics mesh builder new. So in this case, they're all going to be circles, but we can easily like make this something else. Okay, so this is going to be graphics draw mode fill. Our point. So our location for this, well, we have it in the position. So we're going to say, and I guess this would be interesting if we started doing a camera, is like which one, like, oh, well, we wouldn't even draw anything if it's not inside of the camera zone. We would always want to just basically skip over drawing it. So I'm not really sure if the setting the destination separately is that like, well, actually, you know what? I could see it making sense to switch out the destination if for the circle to make it easier for me, I just kept it at 0 to like draw like some kind of weird other shape. For a circle though, it should be pretty simple. And I should just be able to say, okay, this is a point to from, and it's the position. The radius is self dot, no, not self, this is the size. The tolerance is 0.1. And the color, we can set this to white right now, but we should really create a let's see, graphics white. We should probably set some kind of a component to store the color. So, right, then we're going to build. And we have the context here. So build, we pass in the context. We unwrap that. And here we have our mesh that's been created. Can't find value for context. Oh, it's self.context. What? Wait, did I not do that for this one? Oh, render system is going to have to. Oh, it's a tuple. Yeah, so self.0. That's what it is. All right, so that gives us the context. We now have our mesh. In order to draw it, instead of the self.0 to get the mesh, draw takes, oh no, it does context, then the drawable. So this is just mesh like that. And then our draw parameters, we don't need to scale or set the destination. We'll just take our default. And then we'll, of course, unwrap this. And we should be good to go. We don't go through there. Let's see, point, position. How is position done? Okay, it's a tuple. So this is position.02. And size.0. So everything's like a .0, a little bit, it's a little bit weird. I can definitely see potentially storing this as like XY in the position. I don't know, there might be a better way. I could, you know what? I could probably also do this. This is probably more horrible looking, to destructure in here. And now I can just use, I feel like this is a, no, it doesn't like that. Okay, so I can't destructure like twice, which is what I was kind of hoping to be able to do. but it definitely doesn't like that. So .0, .0. I guess I could like create variables and sort of destructure them separately up at top. I guess I'm not going to worry about too much. This seems to be like the pain of using a tuple in here. I can use like a value instead of like, yeah, I could do like a value inside of the component. We can play around with it, see like what type of storage system in these structures we really like for the components. Okay, so if I create this, this is now a system called render system. So in our main, we're now going to do render system. Oh, we pass it into context, and now we we want you to be render system, and we run now. And I think that means we can run this. Cool. Okay, so we create our ever-expanding sort of circle that we have there. Now, another interesting thing is this means we don't need to have context anymore because we're not creating the mesh at this point in time. We're creating the mesh with each frame, which would mean that we could switch back to the new run. I'm not going to do that right now, but that is really good to know that if we don't need the context here, then that could potentially help us out in the future. Okay, so now I want to create two entities, and I want to have subtly different types. So let's begin by creating a color component so that each one can have a different color for us to keep track of it. So struct color. So what if I created like a value, and so that would be like color.value as opposed to like color.color, which would be maybe a little bit odd. Okay, so my other choice is to just store like red, green, and blue separately, like this. And then I can create the color every single time. That would be good if our colors change often. I think with these colors, I'm not going to change them. So let's just have value, and this is going to be a type graphics color. Can it just be a GG color struct? Like, could I set this to be the storage? So I have to tell it to be storage, and I have to derive it to be a component. How would I do that? How would I like actually just set it to use the GG color struct as the component itself? Because I have to tell it that it's a component. Oh, I guess there's the not this way. So what if I do the impl component for position? So what if I do impl component for graphics color, and then I'm going to say I want type storage equals vec storage self, and that should be that. Abstract component type doesn't have to be copy or clone. What's our errors? Only traits defined in a current crate can be implemented for arbitrary types. Impl doesn't use types inside. Okay, so this is basically saying I'm not allowed to like implement these traits for types that, or for like structures that I did not create. So it's a good idea, but Rust is very unhappy with that. So I will, let's recreate this. So we're gonna have struct size. We'll do size color. That's what I'm doing. Color. We're gonna have a value of a graphics color. And then we're gonna derive component. So I am still using just basic vec storages because at the end I want to sort of switch them over to the other type of storage that's default to use and just see if everything works as is. And if we get any like better performance out of it. With a tuple, you could create function value tuple and return t self 0. Then it would be value of size. So I'm not. You can create function val. Oh wait, is that like a is that like a trait that I could do for like the getter of it? Or I guess I'm not really sure how. Well, let's because if I create a function value for impl size, and we want to do this like impl for color too. So let's do pub fn new. We're gonna create. So let's take in like red, green, blue, and alpha. And we're going to return a color. But you're saying like I could also have a function. Well, okay. Basically, you're talking about a lens, like a getter for this. Okay, so I create a new one, and I'm just going to say I want to return color with value that's going to be graphics color new red, green, blue, alpha. So if I do this, this gives me a new color, but I could theoretically do pub function sort of like a getter on it. And this returns, I guess it would turn the type itself. So return a graphics color. And then I would just return, oh right, I need self. I would return self dot value. Something like that. And if I did this, then I could now potentially call this color inside of here, and then it wouldn't be color to color, it'd be like color to get. Yeah, I don't know which one would be better now. I'm not going to do that right now. Let's just see how I feel about the value, like getting the value that way. All right, so I have to pub the value. All right. Now coming up here, so we have our new component color. We need to register that. So world register color. And then, so, okay, with position, with size, dot with color, new. And so let's choose our RGB. So let's make this maybe like red. So that would be 1.0, and then green, so 0.0, 0.0, and then 1.0 for the alpha. And then we're going to build. So that creates us our entity. It should now be red. I don't need our grow anymore. So I'm just going to remove this grow circle system. I just want to display it. Oh, our size. So I don't want 0.0 because like, let's now start with like, I don't know, 50.0. Okay, so I don't want to grow in update. I just want to run the render. All right. Ooh, you were not the right color because I kind of forgot to use that in the in here. So in our render system, we need to also bring in color. So read storage color. So you're gonna be color, color, color. And so now in here, instead of graphics white, we're going to say color dot value. Okay, we don't need you right now. We should have a red circle. All right, so there we go. Now, what I want to do is create another entity. Crosby, hello, good morning. I want to create another entity. So let's do another circle. And put it below this one. But make it blue. Or you know what? We can actually use the random colors, can't we? Because like that works too. But all right. So let's just do blue for right now. So with a new entity, so world.create entity. So world.create entity with. Okay, so we're gonna have a position. The X I want to be the same. So 100.0. The Y, let's double this. So 200.0 dot width. Okay, our size, we'll make this the same. Our color, so let's make this not red, not green, because there's red, green color. Ooh, I forgot to. Parentheses. We'll make this blue and fully opaque. and then we'll build this. Can I cargo FMT it? Yes, I can. I need to figure out how to set up cargo FMT with what is it, with VS Code. All right, so what are you upset about? Expected type found 0.0. I forgot new. Okay, so let's run cargo FMT. That fixes this. Fixes a lot of things. And let's now, I shouldn't need to do anything else. Everything should just, it just work because I'm telling it to like loop through all of the items and run them. So there we have a red and green circle. Okay, so this is how we get multiple entities on the screen. But I now want to have red move to the right and blue not to move to the right. So that is weird green. Yeah, sorry, blue. Like I see it as blue, but then I have dyslexia, so like I sometimes just say the wrong color or read. You know, it's weird. Okay, so I want to now have a type. It looks kind of like a traffic light. Yeah, I can see that. So I'm going to need a type of whether or not it's a mover or not. And so I'm thinking I could have like an enum for types, and that could be a component. And it could just be a velocity. Oh yeah, so look, basically, does it have velocity or not? Okay, that's perfect. Yes, let's just add a component for velocity. So I'll just derive first. Got a component. So storage, it's a vec storage, struct velocity. Okay, so let's maybe try our getter for this one to see how we feel about this. So we're gonna have our velocity, and I'm gonna set this to be a vector 2, F32. Impl for velocity, pub function new. So we're going to take in an x and a y. Return a velocity. And so we're just going to say vector 2, new x and y. And that should be that for there. And then we'll also have a pub function get, and that's going to be a self. We're going to return I guess, like, do we want to return the, we're not getting ownership of it, are we? Right, I forgot to return velocity. And this is a velocity colon like that. It's kind of strange to have a velocity inside of velocity. I know it is. I'm just been trying to sort of like play around with different ways to store these. Now here's the problem with get is I don't necessarily want to give ownership and like return a new copy of this. I would want to return a reference to it. basically I would return a reference to self like that. And then I would just say self dot velocity would be my return value. Argument handles without mismatched types. Okay. Oh, right. I want an actual velocity. I want a vector. Sorry. Yeah, that's interesting. So like I want a vector 2 of f32 to come back. And now we're going to have mismatched types. Self-thought velocity is this vector 2 of f32. This expected reference. So if I return a reference, are we going to get lifetime problems? No. Okay, elision works. I'm not unhappy about that. So now let's give ourselves a velocity. So world.register velocity. So with our first entity here, we're going to give it dot with velocity new. So let's make it move nice and slow. It's like 0.1x and 0.0y. I'm not using delta time for this, so there may be some like maybe a little bit interesting. Okay, so with that being done there, this one does not have a velocity. And now I need to loop through and then make things move. So I need a system to update the location. So this would be something like struct. I guess like it's like can't use move. Well, I could do move system. Move system. I don't need to do that here. I'm doing that because like the fun context thing. This is going to be very different. So we have you. Then we import. We do need the lifetimes here. So system for our move system. So we're going to have our type system data, and we're going to set this equal to a tuple or tuple. How do you pronounce it? Tuple or tuple? I've heard it pronounced like different ways depending upon who's speaking. And so here we're going to need the position and the velocity, and that's all we care about. You've heard both? Okay, so we're going to do read storage. We need the velocity. So velocity. And now we need the write storage for position. So write storage. Write storage for position. And this is all we need here. We don't need anything else. So now we're going to have our function run. We're going to mutate self. We now need our velocity and our position. This is coming from self system data. Okay, so now we're like, why are you upset? because I didn't give a semicolon there. Okay. So now we just want to update the position based upon the velocity. So velocity doesn't have a setter right now. That's a problem because we just get the lens for get. So we need to basically like set this. So pub function set velocity. So mutate self and then a new velocity, which is going to be a vector2 f32. Is it? Wait, what am I doing? I'm not updating. Okay, I'm not doing that to velocity. I'm doing it to position. Position. How am I looking at that? Currently, position is just this tuple. I think that I have access to it. I don't know. It's a good question. So can I do this? Position dot 0 plus equals. I'm gonna try plus equals for a while to see if I like it again or if I still want to go back to like the plus equals position plus. And this is gonna now be the velocity dot get. Oh, I forgot to turn that on. Method fun. You're no fun. Oh, iterate. Yes, I need to iterate. So I run off of this. I need to for, let's see, for, and it's going to be our velocity and position in velocity position dot join. Okay, now I can do this. So now I'm going to say, oh, and so we need to say that position is mutable. I think here. It'll yell at me if it's not. So we're going to say position dot 0 plus equals to velocity dot get. Oh, and I can't forget that inside of run, I also need to say use specs join. Cannot borrow position 0 as mutable as is behind a reference. Okay, I can maybe dereference it. Binary assignment plus equal cannot be applied to type in algebra base coordinates. Okay, so maybe it doesn't have at assign. Oh, you think it means the position part? It seems to be fine. Okay, what if I do position dot 0 plus? Is it like this better? Expected struct n algebra base coordinates xy found struct n algebra base matrix matrix. Okay, so what do we have? We have position, which is a vector 2 of f32. Oh, we have velocity, which we get, which is a reference to vector 2 f32. I wonder if that's the problem too, is that I'm and also like there's potentially, I wonder if like this needs to be dereferenced. So expected structure, n algebra base coordinates xy, found struct n algebra base matrix matrix. On which side? Like, was it this one or this one? I don't know. Let's run it and get the full error message. position 0, I think. Oh, and you're thinking, Danny, that instead of here, we dereference it here? Or maybe don't even get a reference to it? Oh, okay, so that definitely doesn't like that. I wonder if you... I don't think I can dereference there. Oh, isn't there like a deref? Oh, need to mark it as mutable. Maybe I can do this. Cannot borrow position as mutable, and it is not declared as mutable. Okay, so you are mutant here too. Okay, so no errors. So I wonder if I can go back to plus equals. Position doesn't need to be mutable here. Probably because I've those n algebra errors. Yeah. Okay. No errors. Let's now run our move system. So in update here, we have world to self-maintain. But before that, we want to now run this updater. So we'll let our move system equals move system. I think it's just like that. And then we do move system dot run now, pass it in a reference to self.world. And then we run self.maintain. Oh, you need to be mutable. No errors. Let's see if we got a moving ball now. We do. So we're able to loop through and get just get the ones that we're trying to update, but not the other ones. So I think that's perfect. Yay, polymorphism through different components given. Yeah. Okay. So each entity is going to be able to basically sort of like we just hand it whatever we need. We loop through them and then just run run whatever systems on each of those entities, and then it should be fine. So as long as I'm giving them the appropriate components, it should figure things out. Okay, so that's cool. Now, I want, let's say, oh, and everything will have its own velocity because it's going down through the vector and storing that. So like, I don't have to worry about like, if I have two movers, one moves left, one moves right, and that should be fine too. What about the idea of eating each other? Because like, I think that's one of the biggest, like entities eating other entities. Because I think that's something that's gonna be a bit troublesome for us. So let's create another, like a third entity, and put it in a way of the red circle. So here's blue. I'll just copy you. We're gonna do world, create entity with position. So in this one, I want it to be like, I don't know, 500, 100 down, size. Let's make this like, I don't know, 20 pixels. And we can have you some like mix of red, blue and green. and we'll build you. So you will just appear now where I want it to. But as soon as I is sort of moves over and like touches this one, or at least envelops it, I want something to happen. Specifically, I want to be able to eat this ball, but I'm not necessarily sure how to do that. Would that be an eat system? Probably. So let's create an eat system, and just sort of like figure it out as we go along. So struct eat system. We'll impl system for struct eat system type system data equals. So what will we need here? We need all of the positions, all of the sizes. Okay, so we need read storage. We need the positions. We need the sizes. What else do we need? We're letting them eat each other right now. Like we don't have any types, so I don't need to like grab type. And I want, you need the entities too. Do I need an eat component? I don't know if I need an eat component. I might need an eat n component. But I guess like right now I want to just, maybe we'll just console log out. Or sorry, not console log. We'll print line out when we get eaten. We need the entities used. How do I get the entities? I didn't see that in the book. I see joining components. So like, you imagine size will be write storage or something so it can be eaten. Then you'll need the entities to remove the loser. Right. How do I, let's see, remove, or can I, accessing entities? You want to create, delete enemies from a system. There's good news for you. You can use entities to do that. It implements system data, so you can just put it in your system data tuple or tuple. Please note that you may never write to these entities, so you can only use read. Even though it's immutable, there's still like have a delete methods on it. Okay. So type system data, entities like that. And that's that. Okay, so does this give me myself though? That's really interesting. So we'll have, oh, I don't think I have entities. Entities. Okay, so entities like this. This is all of them. And then we have our function run. So we're gonna get mute self. We're gonna get position. Let's say that we want write storage. This to be write storage for size. We can grow the one that we're eating. So this is going to be our mute size, and then all entities. So like entities. And then SystemData. Yeah, when you delete it as internal bookkeeping to delete it on the next world maintain call, right? Okay, so we now want to use specs join. Okay, so for so we're gonna grab position, size, and then I don't think I necessarily want to loop through all the entities here. So in, so this is going to be all the positions and all the sizes. We're going to then join. Okay. So I want to, now how is this? We're grabbing entities here. I don't see it using the entities whatsoever. You see entities. Oh, let stone entities create. So this is just creating it. It's not like deleting it or looping through them. Because basically I want to loop through everything other than the entity that I'm looking at right now. So I feel like I'm going to get into an error when I do this, but we want to check to see if our position plus our size, we need to get the distance between the two. So we have positions. Let's get the distance between ourself, so that's the position here, and the other entity's position. So this is read specs world entity. Can I just do this in here? So like for entity, I guess it would be this, for entity in entities dot join. And so now I'm looping through for every single entity. I'm now looping through all the entities. It's not an iterator. Can I just loop through them like that? Not an iterator. Okay, so join doesn't work on this. Does it need to be a tuple? I'm almost to the place where I was stuck last time. I did sort of figure this part out. Okay, so we're now getting entity. Do I need to destructure it? No, I don't need to destructure it. Okay, so for each position, I have an entity. I want to get the distance between myself and the entity. I think we want position, size and outer, and position, size, and entity on inner. Position, size, and outer, and position, size, and entity on inner. Well, I guess so. Yeah, I do. So like, I almost want to like make this like my position, my size, and then we'll have this other position, other size. Guess, do I even need entities? I do to delete it, don't I? Other entity in. Okay, so now we're gonna have, okay. Like, can I do entity.position? Like, I don't think I can do that, right? Other size, other entity. To remove it, yeah, okay. The lifetimes are easier because you're guaranteed the life of the entities for the entire run of the system because the way that specs works here. Let's full screen this. All right, you need to be referenced like that. You can't rename the component in the join. Wait, I can't? Oh, right, okay. This is still size, and this is still entities. The left can be this other. Now what? Oh, you are mute. So even though I'm not using it mute in here, oh, because now I'm using it twice. Cannot borrow sizes mutable more than once. So that's interesting. Because I need it mutable here, but I don't want it mutable down here. Well, I only need it mutable once, but immutable borrow cannot borrow size is immutable because it's also borrowed as mutable. You need to decide if the inner or outer loop will be winners. Right, but I can't borrow size twice. Like one says mutable and one says immutable. Guess that means inner or winners. Okay, so what if I do this as size is immutable there and mute here? It still doesn't like this because you're not allowed to borrow. So the Rust borrow checker doesn't allow something to be borrowed both mutably and immutably. So that's just sort of like how it's set up, where it's okay. You have like you can have multiple immutable borrows or a single mutable borrow. That's it. Like you can't do both. Can I borrow? Can I get like a system? Oh, you know what I think it is all right, let's for right now, we'll have these be immutable. I'm just going to print out when it print out to that. But I'm going to I can create a component grow by, and that gets increased, and then we have a system to like grow by the system, and then it grows that. So it's a little bit of extra work, but I think that'll handle this. So we have my position, my size, the other position. So we loop through all of the other ones. I guess like the problem that I see here is how do I know which one is mine? Because I'm looping through them twice. And so I need to filter out which one is mine. You can do that in a single system too, just a for loop after the other. Oh yeah, I guess I could like then after these are done, then grow by that. I feel like that system may be too like doing too much then. I don't know. I'm gonna figure that out later. So let's start by getting the distance. So that distance equals, and that's going to be my position dot 0 because it's a tuple, minus other position dot 0. So this will give me a vector that is the distance. And now I want the magnitude of this. So I think I can put this in a parentheses and then do dot, or that makes it a tuple, doesn't it? That's not what I want. I can mute this and now say distance equals distance dot magnitude. Get entity in both and compare to see if they're the same. Wait, I can do that? Also, mismatch types, expected struct and algebra based matrix, found F32. Wait a second. Position. This should be a vector 2 minus the other vector 2. So distance should be an algebra. Oh, interesting. Okay, so like it now sees this as a matrix F32. Oh, yeah. So I'm gonna have to shadow this because distance we now want to be an F32, and this is So that's what I have to do. And now let's okay. So we have our distance now. This is the number of pixels that are distant away from each other. So if I'm moving towards something, if my position, so I guess like if the distance away from me, oh, weird. Okay. I just realized that I'm getting weird like artifacting down here from the outside, like the trees. There's like the shadow of the tree, so I need to close my shades. And that fixes that problem. That was interesting. Like the sun came out, started shining lights all like shadows all over the green screen. Okay, so I can compare against entities. Okay. So my I mean I can call this like me in entities and then other entity into this. Okay, so the idea is that if not, or if me is not equal to other entity, then I want to do all this. Nope. Yeah. Okay, you're not upset about that, so that's cool. Then I want to say, okay, so we have our distance. Let me go to the whiteboard to actually think these through, especially since I have the whiteboard. So if I have myself, I want to make sure that the microphone is on. Yes, it is. Okay. So if I have this circle there and I guess like there's a couple different scenarios we can be in. There could be another one right here, and another one in here, and then those three scenarios is one completely outside, and it could be just anywhere around here. One that's completely inside, that is considered eaten, and then one that's not completely inside yet, that would be other. And so if my xy is I guess if my distance to this is, let's say, like 100, and if this is like 25, and this is like 10, not to scale here, how do I figure out if I am inside? So if I don't necessarily write that number down, I know that I am 25 radius, it's 10 radius, and my distance is greater than its size plus my size. I think that's what it is. For this one, if I take its radius plus my radius, my distance to it is shorter than that. And so therefore, it is inside of me completely. Okay, that's what I'm going to try. All right, so we get the distance between them. Then let's now add our radius, our size, to the other size and compare it to the distance. So if distance, if that is greater than my size plus other size, I think that's right. Okay, so if the distance between the two is greater than my size, oh, you are dot zero. Dot zero. We may still need to mutate size eventually. Okay, so if the distance is greater than this, I am eating. So I am eating. And so to Danny's point is that we could try to handle this in like the next loop over. So we could say size, so like let size increase by equals, we'll start with 0.0 to begin with. This will be mutable. And then I'll just say size increase by is plus equals to the other size, dot 0. I also want to now tell this other entity that it's dead. So we're going to say other entity dot, and I think this had delete. So we'll just tell it to delete. After this entire loop through, now, ooh, you're not happy. No method name delete for type entity in the current scope. Well, that's not, let's see. that stone entities create. That creates a stone. Okay, I thought, is it remove? I thought it was delete because it says delete. Oh, we could try remove. Oh, is it entities delete other entity? Oh, that might be interesting. Okay, so let's do entities dot delete other entity. Oh, there is a result here. This result may be an error variant, which must be handled. Okay, so I'm not returning a result here, so I have to unwrap then. Okay, that might work. So then after this works, well, So I'm looping through all of the positions, all of the sizes, all of the me's. And in each loop, I'm looking through all of the other ones. I can't then do size increase by because then only the last one will get increased by size. So I kind of want to do this inside of this loop where I say, okay, for the other ones, let's see if I eat anybody. And if I do, I increase my size by this and I delete the other entities that are inside of me. And then I now need to tell my size to increase by this, but I don't have my size anymore. It's not mutatable. So I'm thinking that I actually have to create another component for this. So this will just delete that. I now need to go, well, we can run this and the other entity should disappear as soon as it gets like run over. Let's try it. I still have mute size. No, it didn't delete it. Okay. Wait a second. I didn't run it. I didn't run the eat system. Okay. So in our update, we have move system and we want our eat system too. That mute down here, we don't need it all to be mutable. We just know that it's size. Uh-oh. So that didn't work out too well. It just deleted everything. So I think everything got eaten right away. That's not necessarily what I wanted to happen in this logic. They all ate themselves. I think they did. Okay, so if the distance is less than, I think. Did I just dyslexize that? Oh, those two ate each other as soon as they touched each other. Okay, so the math is a little bit wrong. Also, I deleted both entities here. They created a void and popped out of existence. Exactly, yeah. So entities.delete, I think we need to look at how delete works. And this is like the book here. It would be it'd be nicer if they actually showed an example of delete instead of just yeah, because it doesn't have that. It's just like inserting dynamically. So I want delete. I want to delete all entity. Okay, delete entity. So I see a couple ones here. Delete the specified entities or deletes an entity. Delete entity. Okay, so is it delete underscore entity? So is it other entity dot delete entity? Check if the size is greater and don't delete that one. Well, I'm deleting, for some reason I'm deleting both of them, but I'm trying to only delete one of them. And check if the size is greater. Oh, like, okay, my size needs to be greater. Right now you're deleting everything that collides with something. That's not what I want. Yeah, definitely. So let's start this over again. So if I say if, so my size needs to be greater than their size. So if my size is greater than other size. Okay, so I have to be greater than the other size. And the distance between you and me needs to be less than, let's see, the distance, your size plus my size? No. Your full size needs to be then less than the distance to me, I think. So then also distance needs to be less than other size. Plus my size. So if that's the case, then we want to say entities dot delete other entity. So let's see if that works. Dot zero everywhere. Just make sure if you're only eating if you're bigger. Yeah. Dot zero all the things. Oh, dot expect or dot unwrap. So let's start with that. So it ate it as soon as it touched it, which leads me to believe that this should be minus here. And then it should happen as soon as it totally envelops the other circle. No, okay. So math is still a little bit wrong. But the general idea is, okay, I have to be bigger than the other one. But then also, I want to say that the two, so like, how do I know that you're like fully inside of the other circle? If you are, if your rate, so I have the magnitude of the center point's distance with that. If the magnitude, so if the distance between the center of the big circle and the small circle, if that is less than, okay, plus, okay, so if the distance plus the other size, if that is less than my size. I drew out there. I still got the math wrong. Also, oh yeah, no. There we go. Now it gets completely sort of eaten as soon as it hits over it. And then that is, that's like the main big problem that we had last time, is that we couldn't delete the other ones. And now we can with this command. And if I wanted to really, really, really quickly add in the growth system, we'll add a component. So component, here's all our systems. Let's just copy you. I'm gonna make you grow by component. If I just make you a tuple of an F32, so new, this is going to be, come on, stop, mouse, work with me. You are going to be the amount, F32, we're going to grow by, amount. Okay, so if I just do this, I mean, I think the tuples are fine. Okay, so now we're gonna set the initial grow by, so world.register grow by. And I guess they all need to have, all these need to have a grow by. So wait a second. I thought I told you to that command. With grow by new, we're gonna just initialize it to 0. Now we need a system. Oh, why did I put a semicolon on there? Now I need to now I need to have like the grow by system. So this system is a little bit simpler. I'll just copy. Nope, not cut. Okay, so we're gonna have a grow system. We're gonna read storage grow by and write storage size. So run function, you are now, you're going to be grow by, and you're going to have to be mutable. And you are our size from SystemData. Use specs join. Okay, so this is going to be the grow by. This is going to be our size in mute grow by size. Wait a second, I got that wrong. Size grow by is, I actually want both of them to be mutable, don't I? I want them both to be mutable because I want to then reset grow by to 0. So you need to be mutable too. So mutable grow by, mutable size. Our size is going to plus equals to grow by, but then also our grow by is going to be, and it's size dot 0 plus equals to grow by dot 0, and then grow by dot 0 we're going to reset to 0.0. And I think it would actually be easier for us if in grow by we also just had a function in here. So pub function reset. I don't return anything, and I'm just going to say self.0 equals 0.0. And I can just say grow by dot reset like that. What are you upset about? Join, no method named join for those two. So read storage, grow by, write storage. So you need to be write both for these. All right. Tuples all the way. Okay, so we're gonna get the size and set it to be okay. So then now we need a grow by system. At the very end, so let mute grow grow by system equals grow system. I guess it's just grow system. This has to happen afterwards. So now we're going to say grow system dot run now self.world and run. No, okay, that didn't work. Is grow by set in eat system? I thought I registered grow by and I have grow by set to this. Oh, you know what I didn't? I didn't set, yeah. In the eat system, we now need to get grow by. This is gonna be write storage, grow by. So you're gonna be, you need to be read storage. Everything is read storage except for this. So you are going to be mute grow by grow by mute grow by, and then if the others, I also, before I delete it, I guess I can't, I have access to it right here. I now want to say grow by dot 0 plus equals to other size dot 0. That should work. Let's see if we got it. I don't have any time if it doesn't work. So regardless, I'm having to end. And it worked. Perfect. All right. So I think this is going to be our answer, and we're going to be able to move forward with this. However, that being said, I have less than 5 minutes before my stand-up, so I'm going to have to get out of here and go prepare for that. Thank you, everybody, for stopping by and watching, and seeing as I'm learning specs and ECS with Rust. It's actually a lot of fun, and I think that this is going to enable me to do some really interesting things. There's still a little bit more experimentation I want to do before I essentially rebuild the ecosystem project. It's like next time I want to work with like the threading and dispatching, but that will be next time. With that, I hope you're all having a great day and have a great rest of your day. And I'll see you next time on Friday morning. Bye.